Alrighty folks, it's just a little video just on the basics of the cabin heater system that I've installed in the car here. Now, one of the problems that you have when you convert a car to electric power is that you don't have a source of hot fluids as you generally have from the cooling system of a combustion engine car. In fact, the majority of the energy that's available in fossil fuels is basically dumped to the atmosphere as heat energy from a combustion engine. And one positive side effect of that is that you have heat available effectively for free to heat the passenger cabin and dehyst the glass and all that sort of thing. So when you do a conversion, you've got a little bit of a challenge there, because we have to find a different approach to cabin heating. So there's two general schools of thought in this game. The first being that you build a little fluid heater system that basically heats a small amount of coolant and pumps that through the existing heater core in the car. That's got the advantage of that you don't have to take the dash of the car apart to get at the actual heater core. Now, I did a test on this car with that approach some time ago, but unfortunately the existing core had been so badly blocked with crap from the cooling system of the engine that it was just not a practical option for me. So instead of that, I took out the heater core and I put in one of these ceramic heater cores into it, and it kind of half functioned, but I was far from impressed by it. And so over the past maybe fortnight or so, I decided to have a second approach at it. So the first thing that I did was, I had a friend of mine in the States buy 3 of these heaters for me and take the elements out and post them to me. Now the advantage here is that they're 120 volt 1.5 kilowatt elements, and they're a much closer match in voltage to the actual traction voltage of the car than I could get here, because everything here would be 230 volts in Ireland. So these are PTC cores. Now that means a positive thermal coefficient. Now what that means is that these elements have a low resistance when they're cold, and you pass current through them, they heat up and their resistance increases, and the effect of that is that they're a self-balancing element. And I'll be able to demonstrate that when I turn on the heater here in the car. Now these elements actually have 4 parts to them, as you can see by this kind of thermal compound that goes down in the center here. You've 1, 2, 3, 4 excuse me, separate elements inside the this particular block. Now hooking these up, need to think about it a bit. I got some help on it, and you basically have to common up the outside, the 2 outside terminals, the 2 blues, and the black inside terminal here. You basically common those up, and then you take these 2 here, these guys with the red cable on them, and common those up. Then you can put your power in there and you get the full excuse me, you get the full power output of 1.5 kilowatts from the core here. So I've got 2 of these guys fitted inside the old heater core in here. On the E36 BMW, taking the heater core out of the dash is a very simple affair. This glove box area here comes out. It's just 4 screws, and then the heater core itself is kind of in there behind the center console. It's held in by a single screw, so you can simply take that out and the whole heater core pulls out. It's really only a 10-minute job tops. So for me then it made sense to go with the PTC heater core option, and as I say, I've got 2 of them in there for 3 kilowatts of heat. Now some folks have problems controlling these heaters. That hasn't happened to me. I'll explain how I'm doing it. This may suit some people, it may not, but it's the kind of simple approach, and so far I've had this heater on now quite a bit over the past fortnight or so, and it hasn't given me a single issue. So to control the heater, to control the high power from the traction battery to the heater, I've got a switch on the dash here, which is just a little 12 volt aftermarket switch, and that sends 12 volts DC to this Kilovac EV 200 contactor. Now these are very common in EVs for switching on and off the main traction feeds, and they're actually, I believe, in quite a few of the OEM cars also for that exact application, and they're quite a powerful piece of kit in a very small package. This can carry 500 amps at, I believe, 300 volts DC, and it can break a 2000 amp circuit at 320 volts DC also. So I happen to have 2 of these in the traction feeds for disconnecting power, and also as part of the emergency shut off, so that I've got 2 of these guys to break the traction circuit in case something goes pear-shaped. Now I've also got this guy controlling the traction power to the heater core. Now you might say to me, well, why should I have to have a component that can carry 500 amps controlling, you know 20-25 amps to a heater core? Now in my experience, this is the only component that I trust to control high voltage, high current DC power in an EV. There are other components that you can get, solid states. You can spend a lot of time chasing up. I have spent a bit of time chasing up alternatives, but it nearly always comes back to the kilowatt. Now, they're not that expensive either for what they do. If you have a search around eBay, you'll snag these for between 50 to 70 American dollars, and for what they are, that's quite a good price in my opinion. The final piece of the puzzle then is the fuse. This is just a basic industrial holder here. It's 700 volts AC, 30 amps, but the part that I think is good about this particular holder is that when you open it, which is a bit tricky for me to do here, I'll endeavour to persevere, it gives quite a positive break on the actual circuit, as it pulls the fuse out of both ends for you. You don't have to get your finger in there or put a screwdriver in there or something such as that. And if you found that the heater ever stayed on, say that kilowatt stuck on for some unknown reason, then when you can just easily pop the bonnet and just pull that fuse out, and that's it, you're done. There's no drama. The fuse itself is a very important aspect here. This is a DC fuse. It's rated 30 amps. Probably won't be able to see it because of my cheapy camera. 600 volts AC DC, and it will break 100 kA AC and 10 kA DC, so it's more than capable of protecting the heater circuit in this car. And it's got a 30 amp fast blowing characteristic. So these would be the main components of the actual heater circuit. Now, as I've said, some people seem to have a difficulty with the starting surge on those ceramic heaters. I haven't seen that. So maybe it's just the way I've got it set up. But I just haven't had a problem. Yes, there is a current spike when the contactor comes in, but as I say, there's a 30 amp fast blowing fuse in there, and it doesn't cause it any kind of difficulty. So what I'm going to do is I'm going to turn the car on, and we'll do a little bit of a demo. That is, if I can get my keys out of here. So let's turn on the car. Wait for that main contactor to pull in. There she goes. Right, so we've got the BMW set up on current, which I hope we're going to be able to see okay. There we go, yeah, that's coming out okay, I think. I've got a little temperature probe here, little K-type thermocouple. It's just over 10.5 degrees in the car now. It's not a cold day. Or sorry, well, it's about 12 up here by the gear stick, and our battery is fairly well charged up. It's at about 159 volts. So I'm going to go ahead and I'm going to put the heater on to cabin setting. You'll be able to see that. Cabin, full heat, and I'm going to set the fan on speed 2. So the fan is on, and I'm going to go ahead now and zoom in on the BMW so we'll see the current. I'm going to go ahead now and turn on the power to the actual core. So there was a surge up to about 50 amps there. It's now just under 30. And it's starting to count back down, and it'll settle down around 20 amps. If we do the sums on that, 20 times 150 is about 3 kilowatts. And there's a lot of hot air coming out of here now. I'm going to just put the temperature probe now. I'm going to hold it maybe 6 inches in front of the grill. And all grills are turned on here. As we can see, we got near 40 degrees centigrade hot air, about 6 inches in front of the grill. And if I push the probe just inside the grill there now, as we can see, we're practically up over 60 degrees heat just with the probe just literally sitting in the grill there. Excuse me. Now, current has settled down just under 20 amps. Now, the self-balancing aspect of these PTCs is quite interesting. If I take the fan up to speed 3 so that there's more airflow, let's see what happens. So as we can see here now, current has increased to compensate for the increased airflow through the heater cores. And if I take the fan to full speed, you see the current will go around 25 amps or so. And if we take the heater back down to 3 and back down to 2, so this is your self-balancing aspect starting to come into play here. As we can see, air temperature just inside the grill is heading for 65 centigrade. I have to say the cabin, even in the short space of time that I've been filming here, it's well comfortable. If I take the probe out and just hold it in the center here, I'll just hold the probe here for a second or two. We can see our voltage is just gone down a small bit as the surface charge bleeds off. And just under 20 amps. And cabin temperature here, just holding the probe in the center of the cabin. As we can see, it's quite toasty in here. If I was driving, I'd actually be turning the heater off at this stage because it's getting a little bit oppressive in here. If I just leave the probe down in or about where the gear stick is, which is will hold the heater vents, the temperature drops a bit, but still quite toasty. So then, for turning off the heater, what I tend to do is I tend to actually turn the heater itself off. That switch, check that my current has fallen down to 0, and I keep the fan on for perhaps a minute or so just to cool everything off, and that's about it in terms of the cabin heater. So that's it. Everything's cooled down. I can simply turn off the fan blower and turn off the car, and that's it, folks. That's really as difficult as it can be to put cabin heat into an EV. Now, there are obviously issues that it consumes. It consumes extra power than that, but I'm not going to get into that aspect of it. That all depends on your particular pack and all that sort of thing. But so that's about it. That's a very simple heater setup. So sorry for a boring video, but I just thought I'd share this bit of info. Like I say, I haven't had any surge issues or turn off issues when I have the simple kilovac setup going on here. And that's about it for 2011, I think, folks. Hopefully see you all in 2012, and I promise, Ted, I will do a burnout for you. But I'm just holding off on that until my back tyres tread gets to a point that I'd be changing the tyres, and before I do that, I will burn the hell out of them for you, I promise. Okay guys, have a good one, and we'll see you back in 2012.